Hi, everybody. Welcome to today's hearing. I'm Ben from the Things Industries. Welcome. Okay. I've got the chat over here. And so today, we're going to discuss what LoRaWAN networks look like and what specifically LoRaWAN roaming and peering are. And we have some exciting interviews with Ari from Digita, with Johan and with Felix to talk all about how LoRaWAN roaming and peering can create business value for you. But first, I have a 5-minute video covering all of the basics of roaming and peering, and then we'll kick off the interviews. I have the chat over here on the right, and that's chat from YouTube, LinkedIn, Facebook. So if you have any questions, please drop them in the chat. And at the end, when we have our guests on, I will try to answer questions as best I can. This webinar is part of a series of events that we're doing leading up to the Things conference in September. And every week we try to cover one of the basics of LoRaWAN in order to, as much as possible, to build excitement. And then we'll all meet September in Amsterdam, the biggest LoRaWAN conference, the Things conference. So like I said, we have some exciting guests today. We have a 5-minute video that does its best to cover LoRaWAN networks, roaming and peering, and then at the end we'll answer questions. I'll try to leave you some interested to learn as much more as possible. Let's get rolling. Sorry for difficulties. Let's get started with the video, and then we'll do the interviews. Here we go. Welcome to the Things Fundamentals on LoRaWAN networks, roaming, and peering. Today, we'll talk about what LoRaWAN networks look like, and we'll discuss how LoRaWAN roaming and peering can easily allow you to expand your network coverage and add redundancy. We'll take a look at 2 use cases which demonstrate this value. I'm Ben from the Things Industries. Let's get started. On the agenda today, we'll first take a look at a LoRaWAN network. Then, we'll explain peering and then roaming. We'll introduce Packet Broker, a service which enables roaming and peering between any LoRaWAN networks. And then I'll show you how to get started using LoRaWAN with peering and roaming enabled. Firstly, this is what a LoRaWAN network looks like. End devices communicate wirelessly with gateways. Gateways convert wireless messages into IP LoRaWAN traffic and send it to a network server like the Things stack. Gateways are key here in providing coverage. A single gateway mounted on a high point in an urban area can capably provide 10 kilometers radius of coverage. Gateways are inexpensive and can easily be added and configured to route traffic to a LoRaWAN network, expanding the coverage of that network. But since most LoRaWAN networks are private, this can mean multiple solutions providers are covering the same area with multiple LoRaWAN networks. From a technical standpoint, this is no problem, but this is an inefficient use of resources. Reinventing the network coverage wheel here over and over again isn't ideal. Enter LoRaWAN peering. Peering allows network servers that receive traffic for devices on another network to forward that data to the other network. This means that in an urban area with existing coverage, network server operators can share coverage, adding additional use cases on that same backbone. For example, if a smart city builds coverage to install LoRaWAN Bosch parking lot sensors, the same coverage could be used to extend connectivity for a wireless air quality monitoring project, for fire detection, you name it. And the stakeholders can be completely different groups. To support peering, the Things Industries developed Packet Broker, a LoRaWAN backbone service that easily allows network server operators to configure peering agreements. The groups merely make arrangements through Packet Broker to exchange traffic. For overlapping existing coverage, peering can be used to add redundancy. If the same smart city has one LoRaWAN network for parking sensors and one for air quality, why not create a peering agreement and double the amount of gateways each sensor can connect to? The cost of adding gateways is an order of magnitude less than a network outage, and with Packet Broker peering, the value added from that redundancy can be shared with other stakeholders. The next use case is for roaming. Roaming occurs when a device leaves its home network and connects to gateways which then forward that traffic back to the home network. Imagine a logistics company places LoRaWAN trackers on trucks traveling across borders. Creating a single private LoRaWAN network covering all of their routes would be difficult and expensive, But with roaming, they're able to utilize existing LoRaWAN coverage anywhere their trucks travel. In network-dense areas, the logistics company can even take advantage of multiple roaming agreements to benefit from redundancy. Roaming is especially useful for international LoRaWAN use cases. Theft detection devices, for example, benefit from broad roaming agreements as they might show up on any network if they're stolen. If you're interested in seeing how roaming and peering can benefit you, check out Packet Broker. Packet Broker enables peering and roaming between networks and already routes millions of LoRaWAN packets per day. Packet Broker also provides journals to allow compensation agreements for the shared coverage and tracking of what roams and peers. If you're using the Thing Stack, configuring Packet Broker is as easy as checking a couple boxes to control what data you share. To learn to configure Packet Broker, head to the Thing Stack documentation. Information about connecting other network servers to Packet Broker is also available at packetbroker.net. Now that you know how to use LoRaWAN networks, peering, and roaming to your benefit, let's talk about getting started with LoRaWAN. If you're looking to prototype your first LoRaWAN solution, we recommend the Things Network, where you can use the free The Thing Stack Community Edition, which has coverage from tens of thousands of gateways all over the world. The Things Network also has open roaming and peering agreements with many private networks to share that global coverage. Once you're ready to scale your solution commercially, reach out to the Things Industries for an SLA-backed, enterprise-grade private LoRaWAN deployment, either in the cloud or on your own hardware. All the Thing Stack deployments fully support Packet Broker and allow you to configure your own roaming and peering agreements so that you can start benefiting from existing coverage without adding a single gateway of your own. Thanks for watching. Welcome back, everybody. Thanks for watching. Every week, in a webinar, I try to cover the basics of that topic in a 5-minute video. So I know that was a lot of information really quickly. If you have any questions, please drop them in the chat and we'll get to them at the end. Welcome everybody from all of the platforms. We're streaming to YouTube, LinkedIn, Facebook, and I can see questions from everywhere. So next on the agenda, we have some interviews, and then we'll do a Q&A at the end. And for anybody who's just joining, you are watching the Things Fundamentals on LoRaWAN Networks, Roaming, and Peering. This is a webinar leading up to the Things Conference, part of a series of webinars in order to help educate and get people excited for the Things Conference in September. We're going to today by partners from Digita, and then our development expert at the Things Industries, Felix, and I think Johan is coming on for an interview as well. I talk all about how you can use LoRaWAN roaming and peering to create business value. And so we just watched this 5-minute video about what but really powerful part of the LoRaWAN specification. Peering. Roaming and peering allow sharing of LoRaWAN networks with other stakeholders, other users. So the example that we gave, if a smart city, for example, builds a LoRaWAN network to sensors, roaming and peering allow that solutions provider to then share that LoRaWAN coverage to any other potential use case. Use the same coverage to then create a network of air quality sensors to do fire prevention, and if multiple existing networks are already there, then LoRaWAN roaming can be LoRaWAN peering can be really useful for adding redundancy. And gateways are so affordable; it can be really easy to extend the coverage of one network and roaming to share that coverage with other stakeholders. And in the video, we also mentioned developed at the Things Industries to make roaming and peering really easy. Packet Broker basically facilitates agreements between to make it easy to roam and peer. And Felix will have more information about use Packet Broker. But the Thing Stack has packet broker compatibility built in. So it's really, really easy if you're using the Thing Stack to just switch on and off the types of messages that you want to share and networks that you want to share them with. And Packet Broker already routes millions of LoRaWAN packets every day. So it's not just a concept, it's actually in practice. And LoRaWAN roaming and peering, we think can be really, really powerful. And we hope that there are just one more reason to adopt LoRaWAN as your IoT solution. So I've already made a plug for the Things conference in September. If you are interested, head over to thingsconference.com, where there's lots of information about the hundreds of speakers and all of the interesting and exciting LoRaWAN news that will be shared there. So after the webinar, if you want to continue learning, we also have a section of the Things network that's dedicated entirely to information about LoRaWAN. That's the thing. If you go to thethingsnetwork.org/learn, you can continue to educate yourself about all intricacies of LoRaWAN. Today, we can't cover everything. At the Things Network, we also have a way that you can test and certify yourself. So if you're really, really interested in demonstrating your LoRaWAN knowledge, please head over there, learn as much as you can, and then take a test and to prove to everybody that you are a LoRaWAN expert. Coming up soon, you with Ari Kuka from Digita, and then we with Felix Heinz, who is our business development guy at the Things Industries, and I think Johan, if LoRaWAN roaming and peering can create business value for you, and I think Felix will also talk a lot about packet broker specifically, because LoRaWAN roaming and peering are built into the LoRaWAN specification, but the implementation is actually done with packet broker. So packet broker plays a really integral role in enabling roaming and peering in networks. All right, I see Ari is in the backstage here, and so in a second I will bring him on, and we will pick his brain for information about LoRaWAN in general, and also about roaming and peering can provide business value. So Ari is the Vice President of IoT at Digita, and Digita provides digital infrastructure to businesses. So I'll let Ari talk about what he does, and I'll ask him some questions so we can steal some knowledge from him about how LoRaWAN provides business value. You ready, Ari? Here we go.
Yep.
Welcome.
Thank you, Ben. Thanks.
Welcome, welcome, welcome.
Great.
We are joined by Ari from Digita. And so Ari is here today to talk with us about two things. So the first thing that I'm going to ask Ari is how specifically people can benefit from LoRaWAN networks roaming and peering, or LoRaWAN roaming and peering. What insight do you have about that?
Thanks, Ben. It's a wide and broad question. I think foremost, roaming, peering, they are tools to enable you to scale your business and your solution more efficiently. LoRaWAN as a technology, it's a great enabler for many kinds of use cases. And when you're designing a new solution, I think in addition to just designing the technical side, you should also design the business side and how do you scale your product when it starts to become a success. And I think roaming it's a key tool for that. When you need to expand your footprint to several markets, several countries, or let's say within your own country to many areas, like shown in the earlier video, instead of always building your own network infrastructure, you might be able to use something that's already there.
Yeah, that sounds like it makes. And can you talk a little bit about what you do at Digita to give us some perspective?
Sure. I'm heading the IoT business unit at Digita. So Digita provides many kinds of services to businesses. What we do on the IoT front end is we have built a nationwide network here in Finland, and we offer it to our customers, businesses and organizations. So roaming, due to our background, it's very close to my heart, and I see it's an important thing for the LoRaWAN ecosystem as a whole.
Okay. Do you think that LoRaWAN roaming and peering are being utilized as much as you would expect, or that there's still a lot of room for improvement and expansion there?
Certainly, there's plenty of room to improve and expand. I think even though roaming as a technology has been around for a while, I think it's commercially only now starting to really spread and pick up. And I think there's a lot to do, but there's also a lot to gain as the networks become more and more interconnected.
I see. And from a technical standpoint, how do you go about, say, negotiating roaming agreements and actually implementing that roaming? Is that something that you're currently doing at Digita?
Sure, we have a few roaming agreements in place and are actively onboarding more and more of them. Technology-wise, I think you service providers have managed to do it, make it easy. So I think it's mostly a commercial question nowadays. And it seems that now there's a good like a movement in the LoRaWAN operator ecosystem and with companies like you. So everybody sees that this is something that benefits the whole ecosystem.
Yeah, it makes a lot more sense to share existing code, I think, than for everybody to try to build overlapping networks. And one point that we really wanted to emphasize is even if you already have an existing to increase redundancy and to make your network more. I think that there are lots of ways that almost everybody could benefit from roaming and peering. My last question for you, Ari, is what is your quick tip for somebody getting started in LoRaWAN in 2022?
Well, I think what I would kind of pick here is what I already kind of covered actually a bit, is that when you're designing something new, some new solution, LoRa is a great technology, but already on the early phase, plan how your solution will scale. So when you start to succeed and you get customers and you want to extend your footprint into new markets, so that you have already early on planned how to do that. And here we're kind of coming back to the roaming as a one tool to help with that.
Okay, so plan for the scalability of your solution. Thanks a lot, Ari. We appreciate your time. Ari is the Vice President of IoT at Digita OY, and he shared with us today his for success in LoRaWAN in 2022 and how from. Cheers. Okay, so that from Digita, and he shared a couple tips with us. The first was, so if you're starting with LoRaWAN in 2022, if you're building a solution now, think ahead, think about scalability. In the past, I've interviewed quite a few LoRaWAN experts and hammered on. So we've heard, for example, use over-the-air activation. That's a really, really good way to scalably onboard devices, scalably and securely, because it's very easy in the future to then make changes on the network server side that properly. So using over-the-air activation is a great way to think about the scalability. To think a lot about how you're implementing integrations. I remember Adrian, who has done a lot of the back engineering at the things, suggested using webhooks, because those are an incredibly scalable way of then taking the data that stack and sending it out to your end application. And the last tip I remember for scalability is to consider using LoRa basic station. So if you're building your own coverage and you'll be installing gateways, and definitely consider using gateways, which that will save you a lot of trouble in the future in terms of rolling out provisions to those gateways. and ensuring that you have a secure connection between and the gateways. If you are interested in anything about how to build a LoRaWAN network using the ThinkStack, we've got everything that we covered today. So how you activate, how you configure the packet broker, how you connect a LoRa basic station gateway, all of that covered at thethingsindustries.com/docs. The link is down there. Up next, we have an interview with Felix. He is business development master at the Things Industries, and he is going to talk about driving business value from LoRa. I hope you're ready. I'm going to bring you on. In 3, 2, 1. Here he is.
Yeah,
hello, Felix.
Already. Hi, Ben. Thanks.
Welcome on the show. Welcome on the webinar. Do you want to talk a little bit about what you do at the Things Industries, and then with some questions about roaming and peering?
Yeah, perfect. Yeah, thanks for the introduction. Yeah, my name is Felix Heinz. I work in business development for the Things Industry, so I'm involved in lots of projects which are coming up and helping them from the idea to setting up ready to scale.
Okay, and so how do you think about roaming and peering, and how do you think that people could take advantage of that to derive business value?
Yeah, where I do see the superpower, let's say, of roaming and peering is in it allows you to operate networks in the same space which have different requirements. What I mean with that, and where I see the packet broker being utilized actually successfully, is to say I have different networks. They have partly overlapping coverage, and now I'm looking into how I can maybe increase redundancy there. Like how can I optimize for battery life of my sensors? A very typical example we see a lot is that in a smart city environment, the municipality has set up one LoRaWAN network, while the utility provider has set up their own LoRaWAN networks for smart metering, etc. And they are disconnected. So at some point they say, okay, look, there is redundancy. We might have gateways on the same mast in our city. So why don't we resolve that? We enable cooperation between our networks, and we can reduce the operational overhead while catering to both of our sides. We've seen that even in the community edition. So with the Things Network, which is the open community edition, which we are running on the network server side, many people are investing in having their own coverage established. But not only individuals, but also municipal actors, political agencies, which would use that, invest. But the Things Network doesn't have a service level agreement. It relies on the members to keep gateways up and running. So for certain use cases of a municipality or regional government, like flood detection, etc., this quality, or there is no assurance to have that quality on your network. So what they can do is they can just set up a few gateways to cover exactly the critical use cases and still contribute that coverage to the community. Which I think is a super great symbiosis between those applications. And what we also now see coming in more often where packet broker is being used is that there are private LoRaWAN networks, not necessarily with the network servers we develop at the Things Industries, but they say, look, we've established the network already. We know TTN is a great platform. There are great community members there. We want to support them. Can we offload our traffic, which we detect from TTN devices, back to TTN? Like, we just want to contribute that. We don't even want to use that coverage. We just want to offload traffic back to TTN because we like the idea. We like the community behind. And that's something we do. And yeah, I've seen there were questions about the commercial implications already. Like offloading back to TTN is something which we cover at the Things Industries completely. So we love, of course, anyone who would like to contribute to that. So I think it's a great idea, and we support that.
That's really cool. So yeah, if I heard you correctly, roaming and specifically Packet Broker enable this case where you can add gateways to fulfill a commercial use case, but in this case also route traffic to the Things network and give back to the community. And that is a really, really, I would say, altruistic and an interesting case. And just to recap,
not only sometimes it has also very sorry to interrupt, like sometimes they have very practical implications, because if you receive funding from certain programs, there are sometimes conditions connected to it. So it's very much possible to set up a citizen science network which is open or based on open source solutions, and still fulfill the requirements of local businesses to have a high quality LoRaWAN network, which you can rely on when it comes to selling solutions utilizing that.
I see. Okay. Yeah, I think that you've covered a really, really, really valuable and interesting case, and there's a lot of flexibility, I would say, that roaming and peering can grant to LoRaWAN. So yeah, LoRaWAN roaming and peering are the specification that allows this sharing between network servers, and Packet Broker is actually the tool which, in this case, we're using to implement that. So in all of the use cases that you mentioned, I suppose that's implemented with Packet Broker. And so I want to say thank you to Felix, and up next, we have a lot of the implementation of Packet Broker as a service on to talk about some more use cases and maybe some interesting information about Packet Broker itself. Thanks a lot, Felix.
Thank you.
Before you go, I have one more question for you. Do you have a quick tip for anybody who's starting in LoRaWAN in 2022, as somebody who sees a lot of customer use cases?
Yes, absolutely. So I think what the most important is that you are looking into what is actionable information. So IoT always has to be connected to a very, very concrete and as narrow as possible value proposition. It's not enough to only visualize data, but it should be actionable data. How do I optimize the process? Once I have the use case, I can design my IoT and LoRa solution around that. And especially if that already breaks even with the commercials, then we can scale up quickly and we can add additional layers to it. But the foundation has to be right, and then we can adopt, use the LoRaWAN network for different use cases. We can add peering, roaming to it. We can sell the coverage we've established for our core use case. But at this stage, the most successful recipe would be to focus on your core use case and then layer everything around. And again, like we're at your disposal to answer questions, to think alongside you. Like our team has seen a lot, as you mentioned. So do not hesitate. Just reach out to us, pitch your idea, pitch your project, and we can point you to the right partners, or can help you out and avoid a few of the obstacles which we've seen a lot of people hit so far. So I think it will always make it more likely to succeed faster if we can work on it together.
Great. So Felix's tip is to concentrate on your actual use case and fulfilling the requirements of that, and then of course you can build on top. But if you have any questions, reach out to Felix at thethingindustries.com, and on our website you'll find contact information for Go Felix, and we'll bring Johan. Thanks a lot.
Thank you. Thank you.
So we just had Felix, who does business development at The Things Industries, to talk about a really unique use case for LoRaWAN for Packet Broker peering, which is that commercial private networks can also use roaming to then give coverage back to a community network, and that can be especially relevant in cases when there's funding for a project which has a stipulation that some of that coverage go back to the community. So thanks a lot, Felix. And finally, we have Johan, who is one of the primary architects, actually, of Packet Broker. And some implementation details and what the difference is between, like I said, the LoRaWAN roaming and specifications in the LoRaWAN spec and the actual implementation in Packet Broker. So here we go. I see Johan in the backstage, and I'm going to bring him. Hello, Johan.
Hey, Ben.
Welcome, welcome, welcome. Let me put your banner on here. So Johan is the CTO and co-founder at the Things Industries, and he also does back-end engineering and a lot of educating and yeah, just about everything. I don't know how you have time in the day to do all the things you do, but luckily, Johan has some perspective for us about the implementation of LoRaWAN roaming and peering that Packet Broker gives. So Johan, can you tell us a little bit about what the difference is then between the specification and the actual implementation which Packet Broker provides?
Yeah, so the LoRaWAN roaming specification, which is specified in backend interfaces, let's say official LoRa Alliance specification, is really designed for devices that are moving between networks. So that could be that they move from one country to another and they go from coverage from one national operator to another. And that is called handover roaming. That's very complicated, and it's also not being implemented or used today. There's another part of the specification that's about passive roaming, and that means that the network or the end device stays under control of the home network. So the MAC state and everything related to the security and the device address and things, that's all stays on the home network. But other networks that see traffic from those devices is forwarding that to the home network or the serving network. And that's called passive roaming. So that's basically the two flavors of LoRaWAN roaming. The problem with handover roaming is that it's complicated and it's really designed for non-overlapping coverage, and it's not implemented by anyone today. The problem with passive roaming is that it doesn't work well for overlapping networks. So if you have overlapping networks, you have multiple gateways. You can have multiple gateways that receive the same message. Could be your own gateways, could be gateways from other networks, and they can forward everything to you. And that works with passive roaming, and that's also, the foundation of all the LoRaWAN roaming that's currently being done. But the problem is that if you want to go commercial with that, you can't prove as the home network to the forwarders which packet you used and which you didn't. So you get some major commercial challenges there, and that is one of the things that we solved with Packet Broker. And I don't go into all the technical details, but what makes a Packet Broker really different from LoRaWAN roaming is that it allows for individual packet selection. So it allows home networks to select exactly which packets it wants to use from the forwarders. And that solves many of the commercial challenges that we have when roaming goes to scale. That being said, we do implement the LoRaWAN passive roaming interface on Packet Broker. So it's fully compliant with LoRaWAN passive roaming, and we also see that we have customers and other networks that we exchange traffic with, also other LoRaWAN network servers, including Jerkstack and Actility, and we're also interop testing with others. We also have a successful interop with LoRaWAN, by the way, and that goes all via those LoRaWAN passive roaming interface. But again, Packet Broker itself has a few extra features that make it better suitable for commercially scaling in overlapping networks.
I see. So if I understand correctly, then big hang up with the specification is that networks. So in these agreements, you have a forwarding network and a home network, right? A home network is the network that the packets are destined for, and a forwarding network is the network that actually picks up the messages. And since LoRaWAN devices broadcast to all gateways in range, then you might have a situation where if you have overlapping coverage, forwarding networks are forwarding data to a home network, but that home network is also already receiving that data. And I guess in that case, then it becomes difficult to sort out whether there was value from those.
Right. Right. So
yeah,
how are you going to have commercial agreements between the forwarders and the home network if the home network has, for example, 4 different options to choose from? So this is actually really typical with at least our typical LoRaWAN deployments are very often overlapping with other networks. We have the community network, which has a lot of coverage, which is already there, and there might be a private network that has overlapping coverage with the community network. But it becomes really interesting when there is also a commercial public operator in place, or a neighboring private networks that also provide coverage. And so yeah, in that case, you want to be able as a forwarder to make sure that if you forward a message that you get paid for it by the home network, and also the other way around. As a home network, you don't want to pay all the 5, 6, 7 forwarding networks for the same traffic.
Right, and so Packet Broker has a way of allowing the networks to figure out what was actually sent and negotiate agreements. Okay. So Packet Broker then implements the specification completely and then adds this trackability of what's roamed and shared. And also, I know that with Packet Broker, you can choose the types of LoRaWAN messages that you want to receive.
Yeah, actually, and that's there. We have a few other benefits.
Yeah.
For instance, that in LoRaWAN roaming, it's the entire frame that's being sent, including metadata, for instance. And with Packet Broker, you can also fine-tune which part of the frame you want to forward from a forwarder to a home network. So you can say, okay, I want to forward I want this home network to activate their devices via my gateways. So you can, say I support device activations, but not data traffic, or also data traffic, but not downlink data traffic. Or maybe only MAC layer downlink and not application layer downlink. So that level of granularity is also one of the features that makes Packet Broker unique. But again, you should really see Packet Broker as a superset of LoRaWAN roaming.
Okay. In addition to Packet Broker, how does Packet Broker replace or compete with other tools for that are actually used for doing LoRaWAN peering and roaming?
Yeah. So what you could do is, if you are using a LoRaWAN network server that implements LoRaWAN backend interfaces, you can have peer-to-peer connections between different LoRaWAN network servers. What Packet Broker does is basically a central hub. So all the networks basically connect to Packet Broker, and Packet Broker is more of a hub and routes traffic between networks. So it doesn't require you for instance, if you have the ThinkStack open source installed and you want to start exchanging traffic with somebody else, you don't have to change anything of your own configuration. With ThinkStack, you only configure the routing policies in Packet Broker, because all the routing happens in the cloud. So it's really it follows the LoRaWAN roaming hub model, and there are a few competing solutions in the market that basically do the same thing. But again, Packet Broker provides a few additional features that makes it unique. But it also is possible to interconnect hubs directly with each other, and that's also what we did interop testing with Actility, for instance. So Actility operates ThinkPark Exchange, which is a roaming hub as well, and we have a hub-to-hub interface between Actility, ThinkPark Exchange, and Packet Broker, and that allows networks connected to Packet Broker to exchange traffic with networks connected to Actility ThinkPark Exchange without additional interop testing or configuration.
Okay, there's a lot of potential there. Yeah. Okay. And very quickly, do you have a in LoRaWAN in 2022?
Yeah. Well, that's a good one. I would say, well, a lot of tips already, good tips already mentioned before. I would say get something working end to end. Don't try to reinvent the wheel too much. There are really good libraries out there, and make it easy for yourself. There's a lot of things is already done. A lot of mistakes have already been made. There's a lot of content to learn from. And yeah, I also agree with what Felix said before. You can really get a lot of help in the Things Network community if you're doing R&D work. If you have a commercial project, you can always reach out to the Things Industries, and our professional support team is always happy to help you.
Fantastic. Okay, so yeah, get your solution working end to end, and if you need help for a commercial use case, please reach out to us at the Things Industries. LoRaWAN, Johan, how many packets a day does Packet Broker currently route?
I think a day. I think we're just at 1100 per second at the moment. So that is 95 million per day. Yeah.
Wow. Okay. So yeah. So this is not just a conceptual thing. This is definitely something that is providing a lot of value in practice.
Yeah.
And Johan, as a key part of the development, stepping in and providing some insight about it. I'll let you, and then we'll go to questions. Thanks a lot.
Thanks. Thank you. Bye-bye.
Ciao. Okay. So thanks to everybody who's still here. We had guests were Ari from Digita, Felix from the Things Industries, and Johan, all to talk about value added from LoRaWAN, roaming, and peering. And we had some tips about LoRaWAN in 2022. So make sure that you nail the use case at the beginning, and then you can try to scale from there. And then also think at the beginning about the future scalability of your project. Let's see. So I will now go and see if there's any questions in the chat. YouTube, LinkedIn, and Facebook. You can see questions from all those channels. And okay, we got a lot of thank yous. Thank you, Ari. Thank you, Johan. Thank you, Felix. Let's see. Okay, somebody asked about the compensation model for using a LoRaWAN infrastructure. I assume you mean through Packet Broker peering, and Packet Broker I know provides logs so that individual stakeholders can then negotiate their own compensation agreements, and then you have this record. So it's really easy to check back to that and then hold to those agreements. Okay. Oh. All right. Thank you to everybody who joined. And so the recording of this will be up on YouTube for anybody who missed any of it. And then the 5-minute introduction videos are always on our YouTube as well. That's YouTube, the Things Network, and then at the Things Network Learn, we've also got lots and lots of information for anybody who is interested in learning more about LoRaWAN. As a bonus to anybody who is registered for this webinar, we will send a link so that you can then go to the Things Network Learn, read up and then take a certification for free. Actually register for the webinars, and every week we'll do a new webinar and we'll send out new coupons for certifications. Okay, we don't have too many questions. Yeah, like I said, all the videos will be up on YouTube for anybody who missed any part of it. Thanks a lot to Ari, thanks a lot to Johan, and thanks a lot to Felix. And I will see you all next week at next week's webinar. And even if I don't see you there, I hope I'll see you in September at the Things Conference 2020.